Hello everyone, this is your junior high school math teacher, and for week number 2, lesson number 2, I'm going to discuss the trigonometric functions or ratios of special angles 30 and 60 degrees. After you watch the video, you should be able to define the 6 trigonometric ratios of special angles 30 degrees and 60 degrees. And you should be able to find the 6 trigonometric ratios of these special angles. And for us to do that, we will recall the lesson that I discussed last third grading period, particularly about the special right triangles, such as 30 by 60 by 90 degrees triangle. We know that this special right triangle is actually half of an equilateral triangle, such as this one, meaning its three interior angles are 30 degrees, 60 degrees, and 90 degrees. Okay, the corner which has a small square indicating that the angle right here is 90 degrees. And let us assume that the vertices are named by three capital letters A, B, and C. Therefore, the name of this special right triangle is right triangle ABC, wherein angle A is 30 degrees, angle B is 60 degrees. And let us denote the shorter leg having a length of small letter A is the opposite to angle A having a measure of 30 degrees. And side small letter B is the leg opposite 60 degrees, and the longest side is denoted by small letter C. We call this longest side as the hypotenuse. Now let us recall what we have already learned about uh, the properties or theorem relating to this special right triangle. Now, in such special right triangle 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. So if we refer to this right triangle, the hypotenuse is C and the shorter leg is A. Now, based on this property, mathematically speaking, we have C is equal to 2A. Okay? And another property relating to this special right triangle is that the longer leg, which is the opposite of 60-degree angle, is 3 times as long as the shorter leg. Mathematically speaking, that is, based on this right triangle, B is equal to A square root of 3. So it means this longer leg is equal to A square root of 3. And I forgot to uh, uh, take note of the longest side, which is taken from the first property, which is C is equal to 2A. Okay. Now refer to this right triangle for the equivalent of those lengths denoted by small letters A, B, and C. Now C again is 2A and B is equal to A square root of 3 based on these two properties of 30, 60, 90 right triangle or 30, 60, 90 triangle. Now using these properties, we're going to define or find the trigonometric functions of each of these two acute angles. Okay, so let's begin with angle A. And we need to recall the SOHCAHTOA here, the mnemonic to be used in order for us to recall those trigonometric functions or ratios from sine to cosecant. So for acute angle A, we have the following. Sine A is equal to, from the definition, it is what? The opposite leg over hypotenuse. So mathematically speaking, that is what? A over C. But from this right triangle, it is obvious that C is equal to 2A. So replacing C by its equivalent, which is 2A, so this fraction will become what? Of course, angle A or A is actually 30 degrees. So from sine A, this will become sine of 30 degrees, which is equal to what? A over C, to be expressed in terms of A, that is 2A. So A will now be divided by 2A. And at this point, A will be cancelled since it is common from the numerator and denominator. And the resulting fraction will be 1/2. So it means sine 30 degrees is equal to 1/2. Next, cosine of A, from the definition, it is what? Adjacent leg over the hypotenuse. And from this right triangle, the adjacent leg is denoted by small letter b and then divided by small letter c. Now, we need to express both b and c in terms of a. We know that from the relationship or the property of this special right triangle, b is equal to what? A square root of 3, while c is equal to 2a. So both numerators and denominator are now expressed in terms of a. So the resulting fraction would be what? Of course, cosine of A is replaced by 30 degrees because we are referring to angle A. So cosine of A means cosine of 30 degrees, which is equal to what? A square root of 3 for B, and for C, that is 2A. So that is divided by 2A. And you will notice that there is a common factor again. There is a common factor from the numerator and denominator, and that is A. So we can cancel these two A's from the numerator and denominator. And what will remain from the fraction is simply what? Square root of 3 over 2. Therefore, cosine of 30 degrees is actually square root of 3 over 2. Next, tangent of A. From the SOHCAHTOA, tangent of angle A is what? Opposite leg over adjacent leg. So that is A over B. Then, replacing the value, the equivalent of angle A, which is 30 degrees. So tangent of A becomes tangent of 30 degrees, which is equal to A over the equivalent of B, which is in terms of A. So that is over A square root of 3. Again, there is a common A from the numerator and denominator, so we can cancel them out. And what will remain from this radical fraction is 1 over square root of 3. And take note, if we have a fraction with a radical sign, it means this fraction is not yet simplified. So we need to rationalize the denominator, meaning this resulting fraction is to be multiplied by square root of 3 over square root of 3. And multiply numerator by numerator over denominator by the denominator. And the resulting value for tangent 30 degrees is actually square root of 3 over 3. Next. Of course, at this point, we have already defined the first 3 trigonometric ratios of 30 degrees. And right now, at this point, we will now go to the remaining 3, or what we call the reciprocal trigonometric ratios of 30 degrees. And let us begin with the reciprocal of sine 30 degrees. or should I say sine of A, and that is the cosecant of A, which is the reciprocal of sine of A. We know that is C over A. Therefore, cosecant of 30 degrees is equal to C replaced by 2A. So it becomes 2A over A. And again, there is a common factor of A from numerator and denominator, so we can cancel them out. And what will remain from the answer is that cosecant 30 degrees is equal to 2. Okay, next. Secant of angle A or secant of A is equal to what? C over B. Now, both C and B are to be replaced by their equivalent, which is in terms of A. Now, for C, that is 2A, and B is A square root of 3. Therefore, for secant of 30 degrees, that is what? The equivalent of C, which is 2A, and the equivalent of B, again, which is A square root of 3. Therefore, the numerator is 2A over the denominator, which is A square root of 3. Again, there is a common factor of A, so we can cancel them out. And what will remain from here is what? A fraction, which is 2 over square root of 3. Again, this is a fraction which is not simplified simply because, again, there is a radical sign from the denominator. So we need to rationalize the denominator from this resulting fraction. And what will be the simplest form or the simplified form of this resulting fraction is what? 2 square root of 3 over 3, which is the equivalent of secant 30 degrees. And finally, we have the last one, which is the reciprocal of tangent of A, and that is what? The cotangent of A. And that is equal to B over A. And B, as we all know, that is equal to A square root of 3. So the resulting value for the cotangent of A is actually cotangent of 30 degrees, which is equal to B, which is A square root of 3 over A. And A here can be cancelled out. And what will remain from the value of cotangent 30 degrees is what? Square root of 3. So therefore, cotangent 30 degrees is square root of 3. Now, there you have it. The 6 values for the trigonometric ratios of 30 degrees. Okay? And these are the following values. Again, and you take note of these 6 values for the trigonometric ratios of 30 degrees. And we're not done yet because we only define one acute angle, and at this point we have yet to define the trigonometric ratios of another acute angle, which is 60 degrees, which is actually the measure of angle B. So we're done with angle A, and at this point we are now going to define the trigonometric ratios of acute angle B. And we are referring to the same right triangle. So the trigonometric ratios for angle B are sine of B, which is equal to what? Opposite leg B over hypotenuse C. Now for the cosine of B, that is adjacent leg over hypotenuse, so that is A over C. Tangent of B, that is opposite leg over adjacent leg. So the opposite leg is B and the adjacent leg is A. And at this point, the first three, as we all know, are called what? The basic trigonometric functions or ratios. Now for the remaining three, those are simply what? The reciprocal of these first three. And let us have the fourth one, which is the reciprocal of what? Yeah. The reciprocal of tangent of B, and we are referring to the cotangent of B, which is equal to the ratio A over B. And for the reciprocal of cosine B, that is your secant of B, which is equal to what? C over A. And finally, for the reciprocal of sine of b, that is your cosecant of b, which is equal to c over b. And we know that angle B measures what? 60 degrees. So at this point, we are now going to define the trigonometric ratios of 60-degree angle. Let us begin with the first one, sine of B. That is actually what? Sine of 60 degrees, which is equal to, okay, B is replaced by a square root of 3, while C is replaced by 2a. Again, we are using the properties of special right triangle here. So a square root of 3 over 2. Again, a from numerator and denominator is common, so we can cancel them out, so that the resulting value for the sine of 60 degrees is what? Square root of 3 over 2. Okay? Now, for the cosine B, which is equal to A over C, that is what? Cosine 60 degrees, which is equal to, of course, we retain A, but when it comes to hypotenuse denoted by small letter c, we're going to replace c by its equivalent in terms of a. And from the figure, that is what? 2a. And again, there is a common factor of a from the numerator and denominator. So we're going to cancel a from these two. What will be the resulting fraction? Okay, that you are correct. That is 1/2. Therefore, cosine 60 degrees is equal to 1/2. 1/2. Now, about tangent of B, that is actually tangent of 60 degrees equals, again, B is to be replaced by its equivalent, which is in terms of A, and that is A square root of 3. So, the numerator from B, it becomes A square root of 3 over the denominator A. And again, A is common to numerator and denominator, so ika-cancel din natin uli yan. And what will be the resulting value for tangent 60 degrees? Obviously, the value is what? Square root of 3. And then for the remaining three trigonometric values, the cotangent and secant and cosecant, as I've been telling you, again, the last three are the reciprocal of the first three trigonometric functions or ratios. So let us proceed to the next one. We have the cotangent of 60 degrees. That is what? A over B. So we have A over the equivalent of B, which is in terms of A. So that is A square root of 3. So A over A square root of 3. And again, we can cancel A from numerator and denominator, so that the resulting value is what? 1 over square root of 3. Now, if we're going to rationalize the denominator from this value, the simplest form would be what? Square root of 3 over 3. So this is the equivalent of cotangent of 60 degrees. Now, for the secant of B or secant of 60 degrees, that is C over A. We know that C is equal to what? 2A. Because hypotenuse, again, is twice the length of the shorter leg. So we have 2A over A, and again, A is common to numerator and denominator, so the resulting value would be what? 2. Therefore, sine 60 degrees is equal to 2. And last one, the cosecant of B, which is equal to C over B, is actually cosecant of 60 degrees, which is equal to 2A for C, and over the equivalent of B, which is A square root of 3. So again, makakancel na naman yung A. So anong matitira sa value? It's 2 over square root of 3. And again, such resulting value is not simplified because there is a presence of radical sign from the denominator. So what are we going to do? We rationalize the denominator. So we multiply this fraction by what? Square root of 3 over square root of 3. Then, getting the product by multiplying numerator by numerator over denominator by denominator. And that will give you what? 2 square root of 3 over square root of 9, which is 3. Okay, at this point, I have just finished discussing the sine of 60 degrees to cosecant of 60 degrees. Now, for the trigonometric ratios of 60 degrees, we have these 6 values. And please take note of these values of special angles or trigonometric functions or ratios of special angles together with the trigonometric functions or ratios of 30 degrees, the one I discussed earlier. And these are the 6 values. Okay? And that's all for now. And see you next time.